All right, I think I'm going to get on everyone I need to get on. Day 7. We have a quiz tomorrow. Whatever you see on the review today is on the quiz tomorrow. That's it, nothing extra. So I know some of you may say, well, we did this topic in my notes on Thursday and Friday, but it wasn't in the review. That means it's not on the quiz. Okay? Whatever's in that day 7 review you're looking at right now is what you will see on the quiz, nothing more. All right? Nothing more. And I hope some of you guys are ready for it because I'll be honest, some of you guys in this class have been pretty poor effort-wise in the fourth quarter. All right, I give you all this time in class to do an assignment and it doesn't even get turned in on time. Not even close. All right, so please, no love letters tomorrow on your quiz either. What I mean by a love letter, oh, Mr. Carlino, I really thought I knew all this. I don't know what happened. I'm sorry. I don't know what happened either. Here's what happened. You failed. All right, sorry, too harsh, Isaiah?
No, that's fine.
Okay, that's reality. Yeah. All right, that's reality. Welcome to the real world, seniors. All right. So whatever I go over today on the quiz tomorrow, I am not going over everything. I'll go over a few questions just to refresh everyone's memory, and then I'm going to leave the rest up to you to do during class. All right, so let's do it. I'm going to go over number 1 first. Number 1, plot it, and then tell me what the rectangular coordinate is. Before we do anything, I don't want to freak you guys out. These are the only polar coordinates I could find at the time to cut and paste. You will have a blank polar coordinate tomorrow, or graph tomorrow. All right, you'll have a blank one tomorrow. All right, you will have a blank polar grid tomorrow to fill in on your own. So please, really, just disregard all the radians that I put around it. All right, you'll have a blank one tomorrow. So how do I plot for 60 degrees? Well, it's in degrees first. And what does each line represent in degrees? How many degrees are we going here? What's the deal? 15 degrees. So I start at 0, I go to 15, 30, 45, 60. Boom, right here. My R value is 4, which means I go 4 units away from the middle, called the pole. So I go 4 units away towards 60 degrees. 1, 2, 3, 4. There it is. I did not graph 60 degrees. I just think we're at the point now. I don't think I need to graph as well. But if you want to graph it as well tomorrow, I'm fine. I'm not going to take any points off. But there it is, 460 degrees. Questions from you guys? Pretty easy, standard. All right, let me go deep now. Let me go deep to number 5. Oh, hold on. Go back to number 1. I didn't change it into rectangular coordinate. Sorry, I just graphed it. So rectangular coordinate. You have 2 formulas to remember tomorrow, and that's it. 2. The x coordinate is always found by taking your r value times cosine theta, the angle in the problem. That's how you find the x coordinate. So for us in problem number 1, 4 cosine 60 degrees. Now when you go find that number, you better be in what mode? Degree mode, unless you want to convert 60, which I'm against it. It's one extra thing you got to remember is how to convert back to radians. So it's an easy couple button push of your calculator. Put that sucker in degree mode, please. So I'll put my calculator in degree mode. And now I'm just doing 4 cosine 60, and the calculator just gives me what it is, 2. So the x coordinate is 2. To find your y coordinate in rectangular form, you do sine instead, r sine theta. For sine 60 degrees. Same thing, go back to your calculator, 4 sine 60, and that's about, I think I'm going to round to the nearest tenth tomorrow on the quiz, so about 3.5.
So do we need to do rotational arrows on the quiz?
You're not graphing an angle though, Caroline.
Oh, right.
Right? So I wouldn't need to see it in this case. If you did do the angle, I wouldn't care if it's on there or not. Okay, It's only if you graph an angle for me. All right? Good question, yep. So here's my rectangular coordinate, 2, 3.5. And I don't think I'm going to have you graph that tomorrow. Okay, I won't have you graph that. Any issues on 1? All right, let's go to skip over now to number 5. A little bit different. Both of them are negative now. Both are negative. So I'm on number 5 right now. You'll have a chance to finish everything up in a couple minutes. All right, first, the angle. Negative pi over 2. It's got to be out of what, though, for me to graph? Not out of 2, but out of
12.
12. Yep. So multiply it by 6. Positive 6. Don't leave the negative right with the angle. Just multiply by positive 6. So you guys have negative 6 pi over 12. All right, here's where you got to start paying attention. It's negative. So which direction am I going? Clockwise 6 units. Clockwise. It's negative. 1, 2, 3, 4, 5. Here it is, right here. Here's negative 6 pi over 12. Anybody still help me? The R value is negative. So am I going to graph on that line? No. Where am I going to graph? I'm not graphing on the negative 6.
80 degrees from the other one.
Good, Carol. I'm not graphing on the negative 6 pi over 12 line. I'm graphing directly opposite when it's negative. When your R value is negative, you go on the other side, 180 degrees. 1, 2, 3, 4. There it is. There's your coordinate. And then here we go. Find the rectangular coordinate. Please use your original values in your original polar coordinate. Use your original values there. Ready? Negative 4 cosine negative pi over 2. What mode do I have to be in now?
Radian.
Radian, yeah, so just change it. I think you guys are just going to confuse yourself even more if you try to convert all the time. So just put your calculator in radian mode. Literally 4 keystrokes on your calculator. Radian mode. And now go back. What was it? Negative 4. Okay, so negative 4 cosine. Let's get a little fraction template up. Negative pi over 2. 0. Now substitute in sine for cosine to find your y coordinate. Only 2 formulas you got to come in remembering tomorrow. Negative 4 sine, negative pi over 2. Zero 4 is your rectangular coordinate. And hey, you know, I know I'm not asking you to graph 0, 4, but if you look at the polar, yeah, that looks to be where 0, 4 would be on the rectangular, above the y-axis, 4 units. So we're pretty good to go. Any questions graphing or turning it into rectangular? Because that's all I'm reviewing right now. Graphing or putting it into the rectangular. Questions? Next up on the quiz tomorrow, if you go to number 7, rename a point, but don't change the location. Give the point another name, but it does not change the location on your polar grid. All right, so 7. I have 3 pi over 6. There's 2 parts here. I love this question because it's going to make you really think. For part A, you need your R value to be positive, but your angle has to be between 0 and negative 2 pi. Let me rephrase that for you to help you out. If your angle's got to be between 0 and negative 2 pi, I want your angle to be negative. Okay, I want your angle to be negative at the end. R positive, angle negative. Let's see if you guys can help me out. All right, so I got 3 pi over 6. I want my R value to be positive, so keep it. Keep it what? Keep it 3. It's already positive. Done. I got you there. You're done. All right, so now you got to remember the rules. If you keep your R value the positive, if you keep your R value the same, what must you do to the angle to get a different angle? Add and subtract 360, also known as 2 pi. But I don't have to do both here. Why not? My angle's got to be negative, it said in part A. So instead of adding 2 pi, I want to, subtract it. But yes, most of the time when you keep your R value the same, you add and subtract 2 pi. This just gave me a condition that said, no, you got to be a negative angle. All right, let's go. So 3, what's my common denominator? 6. And here's the thing. You guys that have been just busting your butt the entire time this unit, this is cake for you guys. This is nothing, what I'm doing right now. You guys that have been slacking and not doing a darn thing on the assignments, this is going to be brutal. You have no idea what's going on. And I don't want a letter at the end saying, well, I thought I knew what was going on. And no, you didn't. Because you haven't been practicing. So here's my coordinate. 3, negative 11 pi over 6. Questions there? All right, let's go to part B now. Part B says, all right, give me another point though. Your R has to be negative, and now the angle has to be between 0 and positive 2 pi, so make your angle positive. That's what it's asking in part B. R value negative, angle positive. Can we do it? What's got to be my R value then? Negative 3. All right. Now it's not 2 pi anymore. If you change the sign on your R value, what do you have to add and subtract now? Pi or 180 if you're in degrees. Yes. You tell me. If my angle has to be positive, do I want to add or subtract pi here? What's going to result in a positive angle? Add pi or subtract pi? Adding it. Yep, so I'm going to add pi. Change the sign on the R value. You add and subtract pi. Or 180 if you're in degrees. All right, let's go. Negative 3. 6 is my common denominator. So I'm going to be left with pi plus 6 pi. So for part B, my answer is going to be negative 3, 7 pi over 6. Tomorrow, I don't think I'm going to get that specific as parts A and B. I'm just going to say, here's a point. Name another point that will not change the location. All right, so you can add, subtract 2 pi. You can add, subtract pi, whatever you're feeling. Last thing before I move on. Notice how at the beginning your angle was in radians. That means I'm looking for your answer to be in radians. If your answer is in degrees, you will not get any credit. Okay? You will not get any credit if your answer is in degrees and it started in radians. Anything from you guys there? Changing a point but keeping the same location. Ready for it tomorrow? All right, I'll let you do 8 and 9 in a minute. Last thing we need to go over is coterminal, which will be on the quiz tomorrow. Coterminal. So I'll do 10A and 10C with you. Find a positive angle and a negative one. That's coterminal. So I got 620 up on the board right now. 620. Anybody want to help me out? How can I find another positive angle that's the same looking one as 620? That's what coterminal means.
Subtract it by 360.
I could subtract or I could add. Either one. Both answers are going to be acceptable here. If you subtract 360, you're still going to get a positive answer, right? If you add 360, you're still going to get a positive answer. You decide what to do. What do you want me to do, Isaiah? Just subtract it? Well, I got to do 620 first, huh? Oh boy. 260?
Yeah.
Okay.
Yeah.
All right, so there's my positive answer. 260. I could have added 360 as well and got 9 something. All right, how are you getting the negative angle now?
Subtract 260 by 360.
All right, so take that 260 I just found and subtract 360. Yep. It's always 360 with coterminal. So that's negative 100. There it is. You just answered that question. Keep adding or keep subtracting till you get what you need. And then I'm going to do a radian one, part C. Part C. Last time I say this problem is in radians, so your answer better be in radians. If it's in degrees, I can't give you any credit. You got to finish the problem in radians if it starts that way. All right, what do you want me to do to find a positive one here? What should I be doing? Negative 7 pi over 6.
Add 2 pi.
Add 2 pi, yeah. Add 360 as a radian, which is 2 pi. I'm just tired of this. I'm not even asking common denominator. We've done so many of these at this point. Sorry if you haven't been following along. Negative 7 pi plus 12 pi. Five pi over 6 is the positive version. Any suggestions on how I find a negative angle that's coterminal with it?
Subtract 2 pi.
Yep, set negative 7 pi over 6. Now let's subtract 2 pi.
Could you also take the original, what is it, like a 5 pi over 6 and subtract
Yep.
that?
Isaiah asked in class, could I take 5 pi over 6, my positive answer, and keep subtracting? Absolutely. Look at you, boss, huh? You come up with some nuggets every once in a while, I'll tell you. I'll tell you.
Once
Even
in a
a,
blue moon.
that's right, even a blind squirrel finds an acorn. Good job.
Thanks.
Hey. You've come a long way, young buck. You've come a long way since the beginning of the year. I think we both agree on that.
Got a long way to go.
It's true. That's true. Negative 19 pi over 6 is your negative answer.
So are you always multiplying that denominator by the one you're not?
Yeah, it has to be, Caroline, because that denominator is always going to be 1. Right?
Yeah.
Whether I'm adding 2 pi or I'm adding just pi, that denominator is always going to be 1. So yes, you would have to always multiply it by your common denominator. Okay?
Okay.
Yep. All right, so where are you going from here right now? You are opening up Classroom. All right, so please open up Classroom right now. I'll do it with you. And you guys are taking a look at Unit 8. Polars. And then the first thing you'll see below Unit 8 is Review for Quiz 1 answers. So you can open up that file, and as you're doing it, making sure you're doing it correctly. I will be here the rest of class to see if you have any questions or concerns, which is like 20 minutes to work on the rest of it. Okay, and hey, you want to go play some video games or go on your computer, play video games, or just clock out right now? That's up to you. All right, that's up to you. You still need to pass the course to get the Regents credit, by the way. You still need to pass this course to get Regents credit. Oh, I passed the first 3. Okay, that's great. What if you bomb the fourth quarter and then it averages out to be less than a 65? That's going to suck. All right, so you got to keep grinding in this class, everyone. And I'm nervous for a few of you. Ask me any questions if you got them.